Hi everyone, this is Ed Amoroso from Tag Cyber. I have two very special guests today. I've been looking forward to this discussion. First, I have Brad Nadji, who is an advisor to the CEO over at Sertainty. We're going to talk a little bit about Sertainty and the work they do in data protection. I think you're going to enjoy that. And also Ryan Semanchik, who's the president of a company called Transformations that I think you're going to enjoy hearing about. They're in the customer communications management area, and they work very closely with Sertainty. It's kind of cool how the technology has enabled some wonderful features and capability for Ryan and his team. So we're going to learn all about that, and you're going to have fun meeting Brad and Ryan. And it's I'm just so delighted that the guys are here. Brad, we'll start with you. Very nice to see you, Brad. How's everything going?
Great. Thanks very much.
Yeah, why don't you start by just giving us a little thumbnail on Sertainty so we get a little backdrop on the tech. Then I'm going to ask you about how it works, but tell us about the company.
Very good. Well, Sertainty is a sort of a mature private company. It's a mature startup. They have been in business for probably 7-8 years. They have had a product out for 5+ years in the data security market, and have had customers who are using this product to actually run their business and produce revenue. The core of the technology is an SDK. It's a software development kit. It's basically a library of routines that people can take and protect their data with. It's basically designed for data protection. Regardless of whether you're building a new application or whether you're enhancing your existing application, you can take the Sertainty product, the SDK, and enhance the application to provide the type of security, data security that it provides. The approach that they have to data security is very interesting because it's sort of different than the approach that I had seen in my experience. I was running the AT&T laboratories research at some point in time, and the approach we had to data protection usually was network centric. So we looked at network, how to protect the network, the intrusion detection systems, DDoS attack preventions, various VPNs and virtual private clouds, etc., etc. So our approach was really protecting the environment where the data was in. Sertainty's approach is totally different. They are looking at this from a data point of view itself, not from the environment that the data is in. So if you look at all the various protection schemes that exist to protect the data, whether there are policies and procedures, physical barriers, firewalls, networks, computers, etc., access lists, various access control lists, IP access management, all of that are put together to protect the environment where the data is. So the problem with that is that if that data walks out of that environment, that it remains vulnerable. If somebody puts the data on a memory stick or emails it out, etc., and takes it out of that protected environment that exists within the enterprise, then the data could be easily breached. Sertainty's approach is to protect the data itself, and it does that by basically putting the access controls, risk mitigations, and defensive mechanisms that are needed for the data to protect itself within the data package itself. So data is going to be a self-contained bundle that not only has the core data you are trying to protect, in, of course, an encrypted way, but also all the various components that you need in order to make all of that happen. That is the approach that Sertainty has. It's a bottom-up approach as opposed to a top-down. So the approach works within the existing data protection environments. It works in conjunctions with them, but also it doesn't really rely on them to actually protect the data. And sort of, we have seen evidences in the industry where these layers have been breached, network layers have been breached, etc. Computers have been breached, and people have got access to the data. And when that happens, data has been vulnerable and exposed. A good example of it is like about 10 years ago, NSA has had an incident. Ed Snowden, they made a movie about it actually, who was an administrator within NSA, copied a lot of sensitive, highly classified information, and fled and went to other countries and started exposing that information on the internet and caused a lot of embarrassment and data security issues for the United States. Now, if you look at that what happened, you see that he was an administrator, he had access to the files, but as an administrator, he should not have had access to the content of the files. So if that data was protected using Sertainty's protection mechanisms, he could have stolen as many files as he wanted and fled other places. He couldn't get to the files itself. He couldn't get to the contents of the files, and therefore it couldn't have been any issue if the files were protected using Sertainty protection. So there's a subtle difference between controlling access to the files and controlling access to the content of the file that usually gets confused in this sort of data protection schemes that exist out there. The approach that we just talked about is a self-protecting data. Basically, if you want to sort of capture it in a nutshell, it allows you to combine intelligence modules, management governance, authentication credentials, encryption keys, etc., as a package and inject that within the data file itself to allow it to protect itself. Encryption keys actually is an interesting point. Obviously, you encrypt basically anything that goes into this object that we call a protected data. The encrypting keys are automatically generated, they're randomly generated, they're internal to this object and are never exposed, they're never shared, etc. So a lot of vulnerabilities that come from sharing keys or exposing the keys, etc., don't apply here. You know, people are concerned about quantum computing and the effect it's going to have on data security and so forth. That doesn't apply here because quantum computer attacks are based on attacking the public-private key infrastructure, which is used for sharing keys, etc. Those concepts don't apply here. We don't share keys. Keys are randomly generated, embedded within the system, and never exposed. There's no keys or keychain issues existing in this environment. So if you want to summarize what Sertainty product is, it's really based on 3 principles. Those principles are really the zero trust principle, which means don't trust the environment. The environment we talked about, all the security environment, like network, etc. Don't trust it. Work in conjunction with it, but don't trust that they're always secure. Provide your own security within the data itself. That data security, the second principle, says should not be just for the data addressed. It also should address the data in flight and data in use. That means protect the data while it's going from one place to another, and also protect the data while it's being used. And let me say a few words about them. Data address is obvious. You protect the data while it's sitting on the disk. This is what we've been talking about. The in-flight protection of data is actually based on a product we have called smart messaging. And what that does, actually very useful in environments like an IoT environment, where you have sensors that have limited resources, etc., and they usually have to wake up, do something, collect some data, and pass that data to a central location. Now, these IoT basically sensors have limited resources, limited memory, limited CPU, and limited battery power, so they have to wake up, do something, and then go back to sleep. They cannot maintain a VPN, virtual private network, between themselves and the central location because that's costly, that battery power, they cannot afford to do it. So the best solution for them is something like smart messaging, where they wake up, collect the data, package it in a smart messaging packet, and send it to the central location. And that central packaging uses the same self-protecting data principles that we have. That means it can be only opened by the central computer that is receiving the data. No one else on the network, and you can pass the data to an insecure network. No one else on the network, even if they intercept the data, can do anything with it because the data is protected and is only addressed to the central receiving computer that is being addressed to, and nobody else can open it. So that's a very secure way of protecting the data in flight. And the other one is data in use. If you look at the current encryption algorithms, etc., that exist, a person receives an encrypted file, they get a key, they unencrypt it, and they start using it. When they're done, they re-encrypt it and put it back. Problem is that while the data is unencrypted and they're using it, the data is vulnerable. You know, if there's some sort of a malware on their system, it can just steal the entire data and go away. The approach that Sertainty had in this case is that it only exposes the part of the data that you're really working with, you or your application that you have written. The rest of the data remains protected on the disk. So if the data is hundreds of megabytes, only the few K or few kilobytes that you use are exposed and unencrypted and are made available to you. You work with it, and when you're done, you put it back. The rest of the data is protected on this. Very powerful paradigm as far as protecting the data in use. Not many people do that. And the last thing I wanted to mention about the product is that the product has knobs, has controls, and these controls are policy-based. And basically, you can use those knobs to control the degree of protection that you want the product to have, and also provide policies by which you can determine whether the access should be successful or not.
That's a great summary. It's a wonderful summary of the capability. Just want to make sure I get, so this is very different than most data protection schemes that I've seen, or I'm sure that you and I have seen over the years. Maybe just a couple more words about sort of the difference here between this approach and some things that people watching might be familiar with.
Sure. So getting a little bit into more detail of how Sertainty does what it does is that if you look at what you inject inside a orb or a protected data orb, it's basically a set of management controls for managing the identities. Encryption keys, as I mentioned, are embedded within this protected orb. There are policies and controls that you provide there. And then there's a set of engines that do different things like encryption, compression. One of the engines, the main engine basically in the product, is called a P-code engine or pseudocode engine. What pseudocode is a program that, when executed, performs these various tasks that we talked about implementing policies or mitigating actions and so forth. That whole operating system is called KCL, or knowledge control language. You know, the analogy I use to simplify understanding what is happening here is the analogy that is the same pretty much a concept as in the hardware business. In the hardware business, you have a chip, and that chip, if it's a smart chip, it has some form of a firmware or some program embedded within it. And that program is used whenever somebody tries to access the content of that chip or do something with it. That program, it basically kicks in and runs and performs different tasks. Same concept, you bring it to the software business. When you have a data file, etc., we inject it with that sort of equivalent of firmware, which is the KCL in our case. And that KCL is used that when the data is being accessed by our own reader, basically it starts executing that KCL. That KCL tells it, all right, what am I supposed to do? How do I implement the authorization, authentication? How do I enforce the policies? How do I take mitigating actions, etc.? All of that is really a program written in P-code language, proprietary P-code language. And the whole thing is called a KCL, knowledge control language. So that's where the smarts is, and that engine that runs it is part of the reader program that does that. In addition, there are various forms of audit logs and various forms of events that are produced when somebody tries to access that file. So imagine that you are sending your file to various locations over the internet, other countries, etc., but you want to be able to understand what is happening to the data file that you send out. The Sertainty product provides events, just like sensors that you have out in the network, and provide basic information back to the central location saying what's happening to them. The data files that you protect with the UXT technology, with the Sertainty technology, act like sensors that they send back information of who accessed them, when, what was the geographical location that the file was accessed, whether the access was successful, what mitigating action was taken, etc. So imagine you collect all of that information. If you have some form of a security operations center, which you are very familiar with it, you can collect that data, have a map of United States, and you can see all your data files in different places and who's using them and what breaches have happened, etc., etc. You have full control and understanding what is happening to your data using these events and various logs that are generated. Now, let me say a few words about the policies. I keep mentioning policies, but I haven't really explained what they are. Policies are actually fairly important part of the Sertainty product. And those policies are divided really in three categories: time-based policies, environment policies, and activity policies. So you can, when you're building this protected data file, you can say, I want this file to be only accessible within this time period. Nowhere outside that time period it should be accessible. Even if you are an authorized user, you can only access it within the next 10 days. After that, it goes away. You can say it can only be accessed from 9 to 5. And you can say, it can only be accessed on weekdays and not weekends, etc. So you have time and calendar control over when the content of the data file can be accessed. You can also tie the access controls to what we call configuration parameters of the system that is accessing. So you can say this file can only be accessed on this very network, on the enterprise network. If somebody takes this file outside the enterprise network and try to access it, access is going to be denied. And then you can also tie it to a specific system. You can say this file can only be opened on this very system. Nowhere else on any other system it can be opened. That's the IoT example that I mentioned. You can use that policy feature in order to implement that. The other thing which is very useful, actually, I think one of the most useful ones, is tied to a specific geolocation or basically a sort of security perimeter, if you will. So I can send a file to you, Ed, and say, this file can only be accessed from, within 50 miles of downtown New York. And outside that perimeter, it cannot be open, it cannot be accessed, even if you are an authorized user of that file. So you can set this sort of a system-based and location-based policies on the file. What happens if those policies are not met? Then there are a whole slew of mitigating actions that you can have, like you can deny access, you can escalate to multi-factor authentication. One interesting feature, which is fairly unique here, is that while you're building your file, while you're building this protected entity, you can incorporate into that what is called the honeypot. Let's say you're protecting a spreadsheet that has like people's salaries, etc., very sensitive information. You can create another spreadsheet with false data in there. And during the preparation of that protected file, put that false information in there as well. If the policies are violated, you can say, I want you to present that false information to the user. It's called the honeypot feature. And basically, the adversary is going to walk away with the false data, thinking they hacked into the system and got the data. And it's going to be fun to find out what actually happens to that guy when he presents that data. But that's one of the policy options that you have. You can also have the option of, which is really dramatic, but you can have the option of digitally shred the information, writing zeros and ones and random bytes, etc., over it and destroy it, or completely destroy a file. So these are different policies that can kick in and actually, based on what you desire to do, basically take action on what happens to the file when those policies are violated.
That is very exciting, very powerful capability, Brad. Thanks for that very nice summary there. Now Ryan, you have partnered with Sertainty. You run a customer communications management company. Tell us a little bit about how you use the tech to kind of address integrity in your data supply chain as you tried to make sure that those integrity properties are maintained as you provide support for your customers. Love to hear a little bit about your use of the tech.
Yeah, sure. So like you mentioned, transformations, our product is Uluru, and we're in the business of delivering critical customer communication. So our customers are receiving hundreds of files, millions of records on a daily basis, and taking that raw data and creating documents out of that data. So think about any kind of insurance document, a bank statement, a utility statement, something that you get from your healthcare provider that you get on a daily basis. Those documents are being created and then delivered to end users. So security hits us all around that process. Again, it's all confidential data, it's all PHI, and so we brought Sertainty in to help us on a couple of different things. So one, on the front end of receiving and processing this confidential data, and then on the back end to deliver it electronically as well. So I'll talk about the file protection first. So in our world, like, again, these guys are handling so much confidential data. It's just perfect arena for a hacker to come in, or somebody internally to try to take the data and use it. And so we had to come up with a way to protect that data inside the perimeter. And we were able to embed Sertainty's SDK into our software so that when these data owners, for example, the insurance company, protects that file and sends it to the service provider to generate their documents, they're able to embed certain policy. For example, they want to lock it down to a certain location. Maybe they want to shred itself after 48 hours. Maybe they want it to phone home if someone tries to open it in an incorrect location. Because in our world, once that file arrives, at least before Sertainty, the file was unencrypted. It would move around to different places. Different people would have access to it. You never know if it was deleted or not because they're not supposed to keep it. A lot of these types of data have different rules and regulations around it. So they were being able to take it to the data level and put that policy into the data while those files are being processed was really a game changer for us on the front end just from processing files. So being able to get that persistent protection while running it through our software at full speed, which was another important thing. It didn't slow down any of our processes. We're able to process encrypted files from start to finish without ever unencrypting them. So you can imagine what that does for our customers, the competitive advantage it gives them when they're going out to get this business. The data owners see this additional data protection that we can offer. And it just helps them get business. One of our brand promises, beyond being the most complete CCM platform out there, we want to be the most secure. And Sertainty has definitely helped us do that. So that's on the front end from a file standpoint. On the back end of things, we have another product that we've embedded Sertainty in that allows us to encrypt an individual document, just like we do at the file level, but at the document level, and then send that out with certain rules in place. So for example, an end user would register their device with this secure viewer that we've built, and then we would create a document with rules in place that say that document can only be opened on that device. And then we're able to prove when that was delivered. We're able to prove when it was opened. So we've got proof of access. We can guarantee that it was opened by the authorized user on their registered device. And previously in our industry, that was just impossible. So you've got all types, again, of documents from insurance carriers, bankruptcy notices, healthcare documents that traditionally you've always had to print and mail, which is very costly. Once it gets in the mail stream, who knows really where it goes? What do they do with it after they get it? And now to be able to take that to an electronic channel, which is where the world is moving today anyways, at a lower cost, plus making it super easy for the consumer who's used to having to log into a web portal, try to remember a username and password. Now they're able to receive it in the secure viewer that we built with Sertainty, use their biometrics, and pull that document up. So we're giving the providers the security that they need to be able to move it from print to electronic, but then the consumer is getting a very easy way to access that secure document with all the security built in. So all the way from file to document creation to document delivery, we've got this thing fully encrypted, fully protected, no loss of speed, and a full audit trail of every point of access. And in our industry, compliance is huge. So the auditors want to come in, they want to see an audit trail, and we're able to give them every single detail they want from start to finish.
Ryan, were there many changes that you had to make to your underlying architecture when you were integrating the SDK, or was it something that didn't require much? What was your experience?
That's really been one of the best aspects of it because we were able to embed that SDK right into our product. And it didn't really change anything. So our clients can come in and they can turn on all the different features literally with a checkbox, and they don't even notice a difference. So other than adding some features for them to turn on, the product works exactly the same. It runs at full speed. It was really easy, really easy
That
process.
saves a lot of time and effort, that's for sure. So, Brad, it must be nice to see that tech applied in a use case like that. Seems like a really nice combination of the underlying technology and the business use case. Must be nice to see that.
Yeah, absolutely. Actually, seeing it at work as opposed to just being view graphs is really interesting. The one thing I forgot to mention is the certification process that we went through. So in order to satisfy customers like Ryan here, we had to go through a detailed certification process as far as white box and black box certification, where your source code is run against various lists of potential vulnerability, and also the black box certification, where you actually are there are ethical hackers and sort of industry experts in hacking. They're going with various tools, trying to inject codes and sort of go to kernel debuggers, etc., trying to break your code. And took about a month and a half. We came out 100% clean as far as their certification was concerned. It was we haven't done it in the past couple of years, so it's been really to satisfy customers like Ryan to make sure that their product they're getting is fully secure.
Well, Ryan, let's with you, for anyone who might have some interest in contacting you and your team, what would be the right place for them to be in touch with you guys about your very fine solution?
Yeah, so you can check out our product website, which is www.uluru.com, which is uluro.com. Again, my name's Ryan Semanchik. My email is ryans@transfrm.com. So transform without the O. Shoot me an email or visit our website.
So Ryan, first for you, thank you so much for taking the time. Best of luck in your with your team and with your work. And Brad, always nice to catch up. You know, you and I have colleagues at AT&T, and it's so wonderful to see
Absolutely.
you.
It's good to see you.
Yeah, it's great to see you. So thank you both. And for everyone else watching, we'll see you all next time.